The final lesson in Unit 1 deals with angle-pair relationships. Our learning target for today is I will solve problems using angle-pair relationships. So our essential question is, how do I solve problems using angle-pair relationships? All right, so our first vocabulary word is adjacent. Two angles are adjacent to each other and share a common side. You have a common vertex here. You have a common side, and there's no overlap between these angles. Okay, there are no common interior points or no overlap. These are called adjacent angles. Let's highlight that so that you can make a note card. Next up, two angles that are opposite from each other or across from each other on intersecting lines. So let's see what that looks like. Well, we would say that angles 1 and 3 are vertical. Angles 2 and 4 are vertical. And vertical angles are always congruent. That's very helpful when we're solving problems. And you saw vertical angles in middle school. Yet another vocabulary word for us. Next up, we have my favorite angle-pair relationship. Two angles that are supplementary and adjacent. What does that look like? Well, it looks like this. They form a straight line. Or a straight angle is another way to look at it. These are called a linear pair. I love them. There are a lot of lines in geometry, and because they're supplementary, I know they add up to 180 degrees. You'll see these quite frequently. Next up on the list, two angle pair relationships you learned about in elementary school. Let's begin with complementary angles. Complementary angles have a sum of 90 degrees. Now, complementary angles can be adjacent, but they don't have to be. Okay, I could have a 40-degree angle here, a 50-degree angle over here, and those are still complementary. So complementary angles can be either adjacent or non-adjacent. We also have supplementary angles. Supplementary angles have a sum of 180 degrees. Supplementary angles do not have to be adjacent. I could have 120 degrees here and a 60-degree angle over here to the side. They add up to 180. They are supplementary. If you have adjacent supplementary angles, the best name for them is a linear pair. Complementary and supplementary. I used to have a hard time when I was in school remembering which one was 90 and which one was 180. So I learned that when you do something right, you get a complement. So complementary angles, right angles, 90 degrees. Another way to look at it is to look at your capital C and your capital S. If we connect the ends of the C, we get the 9 and 90 degrees. And if we connect the ends of the S, we get the 8 and 180 degrees. A third way to remember it is alphabetical order. C, then S, 90, then 180. 3 different options for helping you remember that. It doesn't matter how you remember it, but it is important you do remember that angle pair relationship. So let's take a look at a few of these. How do I identify angle pair relationships, and how do I find angle measures using angle pair relationships? Well, sometimes it's straightforward. In this case, X and 112, these are vertical angles. Vertical angles are always congruent, so X will equal 112 degrees. In our next example, we have this lovely little right angle symbol prompting me for complementary angles. Complementary angles add up to 90 degrees. So X will equal 22 degrees for this example. Our third example, we have a straight line. This is a linear pair. Linear pairs are supplementary, so they add up to 180 degrees. 56 will be our value for X. The next example is a little more complicated. We have more than one way we can approach this problem. The first thing I notice is that I have vertical angles, Y and 43 degrees. I also notice that my X and my Z are vertical, but I need at least one of those values before I can find the other. One of the things I like to do when diagrams get complicated is I like to take a note card. And I like to cover the part of the diagram I'm not looking at. Okay? So I covered up the top part of this diagram so I could clearly see that Z and 43 degrees are supplementary. They form a linear pair. So I can do Z plus 43 equals 180. Z is going to equal 137 degrees. I could also look at it this way, covering up the bottom left-hand side of the diagram, noticing that X and 43 form a linear pair. Options, and you are welcome to use a colored note card to help you cover up diagrams and see things a little more clearly. Our next example gets even more complicated. 1, 2, 3, 4, 5 separate angles up here. The first thing I notice is my right angle symbol. I've got a 90-degree angle here. Okay, and I find that really useful because if this side is 90 degrees, so is this side. And that means Z plus 72 equals 90 degrees. So Z is going to be 18 degrees. I'm going to label that on my diagram. Okay, the second thing I notice is that 72 and Y are vertical angles, so they're congruent. Okay, and then this leaves me with trying to figure out X. If I bring that note card down, and cover up part of the diagram, I can see that x and 72 are supplementary. They form a linear pair. So x plus 72 will equal 180 degrees. X is 108. There are probably 5 or 6 different ways for you to solve this particular problem. The order that you find your angle pair relationships in really doesn't matter. It's all comes down to which angle pair relationship you see first. I like that about geometry because there's more than one way to solve something. So how do you find angle measures when you're not given a diagram? Well, you better make sure that you draw and label a sketch. Remember that labeling is the same as annotating. Annotate's one of those words you're hearing a lot in all of your classes. You annotate text in English in particular, and labeling in mathematics is the exact same thing. Angles 1 and 2 are vertical angles. So let me draw myself some vertical angles. Angles 1 and 2. If the measure of angle 1 is 105 degrees, label that. What is the measure of angle 2? Well, I know that vertical angles are congruent, so the measure of angle 2 will equal 105 degrees. Watch your notation as you're writing your answers. Angles 1 and 2 are complementary. Okay. If the measure of angle 1 is 64 degrees, labeling my diagram, find the measure of angle 2. Well, I know that complementary angles add up to 90 degrees. So in this case, x would be 26. The measure of angle 2 equals 26 degrees. Try this one on your own. Pause the video. Check your work. Make sure you drew a linear pair, that you labeled it correctly, and then solve the equation. So how do we do this when we've got algebra involved? I love combining algebra with geometry. And it's important that we do this all the time because they combine algebra with geometry on the SOL, the SATs, the ACTs. So let's annotate or label this diagram. The measure of angle PQT is 3x plus 47, and the measure of angle SQR is 6x minus 25. Find the measure of angle SQR. When I look at this diagram, I can see that I have vertical angles, and vertical angles are congruent. So I'm going to set these two expressions equal to each other. Let's subtract the 3x from both sides. Let's add the 25 to both sides. Divide by 3, and x is 24. To find the measure of SQR, however, we've got to substitute that 24 back into the expression. Now, I'm finding this to be, I think I've done my math correctly. Let me do a little bit over here to the side. Yeah. All right, so the measure of angle SQR is 119 degrees. I want you to pause the video and try the rest of the problems on this page. All right, so the very first piece of information told me I had a 90-degree angle where ray CD meets line AB. I use that information to say my two angles, DCE and ECB, were complementary, and I solve for x. Then I substituted x back in, and the measure of angle DCE is 72 degrees. Take a moment to write your summary. Make sure you are including the critical vocabulary from this lesson.